So today our focus is going to be on comparing and ordering rational numbers. And so in 3-2, we place rational numbers on a number line. And if you remember, a rational number is a number that can be divided or can be written as a quotient. So any number that's going to be written as A divided by B is going to be a rational number. So our rational numbers are going to be decimals. So I could have this is considered a rational number. 1/2 would be considered a rational number. -3 would be a rational number because I could write it over 1. So we're going to be working on comparing and converting rational numbers. We take a look at how we can compare and order rational numbers. The first way is going to be using what we did in 3-2, where we're simply placing rational numbers on a number line and then being able to compare. And then I will show you guys another way, which is where we are going to convert forms. So if I have the following numbers, if I have 2/3, 1 and 75 hundredths, and -75 hundredths, I want to order this in least to greatest. So if I use a number line to go ahead and order them in least to greatest, first thing I'm going to do is I'm just going to put numbers on that I know. So I need to first identify what my number line is divided up into. So I'm going to count from 0 to 1 and see how many spaces I have. So I have 1, 2, 3, 4. So because there's 4 marks from 0 to 1, that is going to be fourths. So each one of these is representing 1/4. So then that makes that pretty easy to locate a couple of numbers. So I'm going to start with 1.75 because I know that 3/4 is equal to 75 hundredths. So I'm going to go ahead and I'm going to place that on the number line of where I think that needs to go. So 1 and 75 hundredths, it's going to be 3 ticks past the 1. So it's going to be 1, 2, 3. So I'm going to go ahead, graph it, and label it 1.75. And then I'm going to do the same thing with the next value that I know, which is going to be negative and 75 hundredths. Now remember, we talked about with rational numbers that when we get into the world of negatives, the smaller number is the number that's further away from 0. So negative 75 hundredths is going to not be past the 1, but it's going to be 1 in front of the 1. So negative 75 hundredths is going to go there. And then I take a look at 2/3. So these two values are both in decimal form. So I'm going to go ahead and I'm going to take 2/3 and I'm going to write that in decimal form. So when I convert that into decimal form, remember we said that we can write this as a quotient. So I'm actually going to divide 2 divided by 3. So if I take 2 divided by 3, I want to do an actual division problem. So if I take 2 divided by 3, let me set that up. 2 is going to go inside the box. Now we've been working a lot with division where the larger number is what always goes inside the box. But remember last year, we really dove in deep and we said that it is the dividend. 2 is my dividend, 3 is my divisor. So 2 is my dividend, so it goes inside the box. 3 is my divisor, it goes outside the box. Well, we know that 3 cannot go into 2, so I'm going to go ahead and put my 0, put a decimal. Once I put that decimal, remember that decimal allows me to add as many zeros as I want past that 2. So 3 is going to go into 20. 6 times, and I get 18, subtract 2, add another 0, 3 goes into 20, 6 times, I get 18, subtract 2. Now, at this point, I'm hoping that you guys are recognizing that pattern on there. And that pattern that you guys are seeing is that every time I divide into 2, I end up with a remainder of 2. So this is what we would call a repeating decimal. So I have 66 hundredths. So 66 hundredths is going to be in between my half mark and my 75 hundredths mark. So I'm just going to go ahead and I'm going to mark it. But when I label it, I'm going to label it 2 thirds. So that's how I can write it on a number line. And then I also showed you that we talked about converting forms, so I can convert it a fraction into a decimal. So we're going to spend some more time looking at the converting forms than we are going to be placing a number on a number line. Okay, so the order that would be in then from least to greatest would be 75 hundredths, 2/3, and 1 and 75 hundredths. Okay, so go ahead and take a look at your work. So I'm going to go to number 2, and it says explain how the inequality -3 degrees Celsius greater than -7 degrees Celsius describes how the temperatures are related. So we talked about this. And so when we're in the world of negative numbers, right? Negative numbers, the closer the number is to 0, the bigger the number is. I always think about it in terms of weather. I would much rather be in -3 weather than in -7 degree weather. So -3 is greater than -7 degrees because -3 degrees is warmer than -7. Okay. All right. So we have on number 3, we have the use the number line to help us get these numbers in from least to greatest, but I'm also going to convert forms. And so I'll put it on the number line and then I'll go through and I'll convert. So the numbers that I have are 1.3, -3/2, -1.2, and 1 and 1/2. So again, the first thing we need to do is we need to look and we need to see what our number line is divided by. So 1, 2, 3, 4. So let's take a look at that. I need to update my number line, so give me just a second to update the number line. I updated the number line, did some voodoo magic of stopping and pausing and fixing things. But here's my number line. So if we go ahead and we count, so I have 1, 2, 3, 4, 5. So I have 5 values between 0 and then the next number that's marked, which tells me that each one of these tick marks is going to be equal to 1/5. So 1/5 is one of the values. A nice thing though is I'm going to go ahead and I'm going to convert that, and I want to know what 1/5 is in terms of a decimal. So there's a couple ways that I can do that. Yep, I can do 1 divided by 5, and I can find it that way. But sometimes this method is not always going to be the fastest way. If I have a denominator that I can turn into a place value, so place value being 10, 100,000, I am going to go ahead and create an equivalent fraction. Well, here I can, because 1/5, 5 can become a 10 in terms of an equivalent fraction, and 2/5, or 2/10. Yep, sorry, 2/10, not 1/5. So each one of these values is going to be worth 2/10. So that might help me when I go to graph things on where things need to go. So knowing that, almost all of my fractions or all of my numbers, I have an even split. I have 2 that are in decimal form and 2 that are in fraction form. So I need to go ahead and first and just make them all the same form. So I'm going to convert. And generally, it's going to be easier to convert your fractions into decimals than decimals into fractions, because sometimes I have funky denominators, whereas my decimals are always going to be tens, hundreds, or thousands. So I know that 1.5 really in decimal form is going to be equal to 1 and 5/10. And then if I do 2 and or 3/2, I'm going to go ahead and I'm going to say, okay, so I have -3/2. Well, 2 goes into 3 one time with 1 left over. So I really have -1/2. So that makes that easy to see. So now they're all in decimal form. So now it's really easy to go ahead and get them in numerical form. So if I were to just look at by getting them all in the same form, I can go ahead and I can very easily get them in order. So my smallest value is going to be the -1 1.5 because it's the furthest away from 0. So negative 1.5 is going to be my smallest value. My next smallest value is going to be negative 1 2/10. My next smallest value is going to be, comparing decimal place value, there's a 3, there's a 5, is going to be 1 3/10. And then my last value is going to be 1 5/10. So just simply by converting my two fractions into decimals, it was very easy for me to go ahead and get these numbers in order because they were all in the same form. So if I go ahead and I do this, and I take a look at my number line and put them on my number line. So 1.5 is going to be about here. So I'm going to go ahead and I'm just going to mark about where 1.5 is going to be. And so there's my 1.5. There's my negative 1.5. Here's my negative, this one right here is my negative 1 2/10. This is my, right in between this fraction and this fraction is going to be my 1 3/10, because again, each one of the line values has a value of 2/10. Okay, so I know that that number line, you guys are looking at that and going, I don't know that I like the number line as a method. And truth be told, it's helpful to see as a visual, but I find it to be faster to just go ahead and convert them all into the same form. So let's go ahead and do a couple of those and take a look at what it'll be if we convert them all into the same form. So when I take a look at a couple of comparisons, I'm going to start with some of the ones that are going to be a little bit simple where I don't have to convert forms. So if I take a look at negative 12 and negative 15, this big circle is where I'm going to put my comparison symbol. I have to say whether negative 12 is greater than negative 15 or less than negative 15. Well, it's going to be greater than. Because again, if I think about it in terms of weather, I would much rather be in negative 12 degrees weather than negative 15. Negative 12 is closer to 0, so it is a larger number. Negative 1/3, negative 1. Well, negative 1/3 is the smaller value, so it means it's closer to 0, so it's going to be greater than. Negative 2 to negative 2 1/10. Again, I look for which one here because they're both negative numbers. Which one is the smaller value? That's negative 2. And because it's the smaller value, it's actually going to be greater. Because when we deal with negatives, the smaller the value is, the greater the number is. Whereas when we're dealing with positive numbers, the smaller the value, the smaller it is. The larger the value, the larger it is. Okay, now let's take a look at some ones that we are going to need to convert. So if I have 7/10 and I have, comparing that to negative 85/100, and I take a look at this, they're not in the same form. But what's nice on this one is I have a positive and I have a negative. Positive values are always going to be greater than negative values. So that one was a little easy to see. But if I have this one, 66/100 compared to negative 3/4, these aren't the same forms. So what I would need to do is I would need to know my conversion for this and say, 3/4 is that. If I don't know the conversion, I need to divide. And so when I divide, I need to go ahead and put my dividend inside the box, which is 3. It's the top number is the dividend. And then I'm going to divide. So 4 goes into 3, 0 times. And then so we add that 0. 4 goes into 30, 7 times. That becomes 28. Subtract. I have 2 left over. Add my next 0. 4 goes into 20, 5 times. That's 20. So 3/4 is equal to 75/100. So 66/100 is going, negative 66/100 is going to be greater than negative 75/100 because this value is closer to 0 than this value is. So again, noticing that if I don't have positive and negative numbers, but I have the same side, so here I'm looking at both negative numbers, I want them to be in the same form to compare. It's going to make my life so much easier when I do those comparisons. Okay, so if we take a look at one more, so I have negative 4 1/2, and I'm going to compare that to negative 3.9. So negative 4 1/2, if I make that into a decimal, that's an easy one, right? Half is written as 0.5, and then I compare. This value is larger when it's just a positive number. So if I have it just as a positive number, -4.5 is a larger value. But because it's a negative number,